Hello everyone, this week we have a new topic called Material Requirements Planning. I will shortly call this as MRP. Let's firstly define MRP. MRP is the key piece of logic that ties the production functions together from a material planning and control view. With MRP, we determine the number of parts, components, and materials needed to produce each end item. Besides this, MRP also provides the schedule specifying when each of these items should be ordered or produced. Here we have an example for an iPad. These are the components of an iPad: memory, touchscreen and display, processor, cameras, Wi-Fi and sensors, battery and power management, other items, box and charger, etc. And to be able to produce an iPad, MRP determines the amount of these components and exact time to produce these components or order these components. Also, in fact, this example is about estimating the cost of an iPad. We can estimate the cost of an end item by evaluating the cost of each component. Let's talk about the production plan. Production plan is a complete specification of the amounts of each end item or final product and the exact timing of the production lot sizes and the final schedule of completion. And we can break down the production plan into several component parts. These are, firstly, Master Production Schedule MPS, secondly, Materials Requirement Planning MRP System, and lastly, the Detailed Job Shop Schedule. You may remember Master Production Schedule. We talked about that in the previous week. Let's remember MPS. MPS is a time-phased plan specifying how many of each end item the firm plans to build and when. You know, the companies have aggregate plans. Here, an aggregate plan is given for 2 months for mattress production. In the MPS, we disaggregate this aggregate plan. Here, in fact, the company has 3 different mattresses. Here we see the models, and also we determine the exact time to produce these models. We make a production plan weekly for these 2 months. And here, the 3 major control phases of the productive system. In the first phase, we have MPS, just we talked about. And in the second phase, we have MRP. And in the third phase, we have detailed job floor schedule and requirements for raw materials. And the success of MRP systems is really related with the integration of these systems. And now I will talk about MRP system structure. There are 3 main inputs for MRP system structure. The first input is MPS, that states the number of items to be produced during specific time periods. The second input is the bill of materials, which identifies the specific materials used to make each item and the correct quantities of each. And lastly, the inventory records that contains data such as the number of units on hand and on order. And these 3 sources, MPS bill of materials file and inventory records file, become the data sources for the MRP program that expands the production schedule into a detailed order scheduling plan for the entire production sequence. Here is a figure showing the inputs of the MRP system. Here we have the MRP, And as I mentioned, MPS is one of the important inputs of MRP system. And here, before MPS, you see that we have aggregate production plan, and forecast or demand from customer is the input for this aggregate production plan. And with this aggregate production plan and orders from the customers, in fact, creates the MPS. And also besides NPS, below materials and inventory records file are other inputs of MRP systems. I will talk about these two inputs in more detail, below materials and inventory records. And here are the outputs of the MRP system. First, the primary reports. These are the plant order releases for inventory and production control, and also secondary reports as exceptions reports, planning reports, and reports for performance control. And here we have bill of materials. Let's define what a bill of materials is. It is the complete product description listing the materials, parts and components, the quantity of each item, and also the sequence in which the product is created. Here we have a simple bill of materials. Our final product is A, and to be able to produce A, we have two components as B and C, and we need B at an amount of 2 and C at an amount of 3. And also we have a second level. To be able to produce these components, for example, to be able to produce B, we have to produce D and E, and in parentheses the required amount of these components are given. And to produce C, we need 2 units of F, 5 units of G, and 4 units of H. And for example, in this bill of materials, also the lead time of the components are given. Here we have the end item. To produce this end item, we need A and B. These are the lead time of the production lead time of these components. And again, we have a second level. And to produce these components, we have to produce the components in the second level. And also the lead time of these components are given. And in fact, these are really simple bill of materials. For complex products, we can even have, for example, 15 levels. And the other input for the MRP system was inventory records. For each of the raw materials, components, etc., we have such inventory records that we keep in the system. For example, here is the master data segment. Here we can have the description of the component, lead time, safety stock, setup, and what else, for example, the order quantity are all kept in this part. Here we have inventory status segment. Here we have the inventory of that component, and we can also have extra data in these records. And also this is an important input for the MRP systems. And MRP programs are integrated into ERP systems by companies such as SAP and Oracle. And the MRP systems operates using information from the inventory records, MPS, and bill of materials. And the process of calculating the exact requirements for each item managed by the system is often referred to as the explosion process. Now I will give you an example about this explosion process. And working from the top level downwards in the bill of materials, requirements from parent items are used to calculate the requirements for component items. And consideration is taken of current on-hand balances and orders that are scheduled for receipt in the future. Now I will give you an example for this explosion process. In this example, there is a music company called Harman producing a variety of instruments. And the company is relatively small and it would like to minimize the amount of money tied up in inventory. For this reason, production levels are set to match predicted demand as closely as possible. In order to achieve this goal, the company has adopted an MRP system to determine production quantities. And one of the instruments produced in this company is the Model 85C trumpet. And this trumpet retails for $800 and it is reasonably profitable item for the company. This figure shows the components of this trumpet. And here is the bill of materials for this trumpet. Here we have the end item trumpet and we have components, bell assembly and valve casing assembly. And the amount of these assemblies required for the end item is 1. And to be able to produce valve casing assembly, we need 2 more components called slide assemblies and valves, and the amount of slide assemblies required is 3, the amount of valves required is 3. Here we also have the production lead times for these components as given in the boxes. And now here the intended bill of materials for the trumpet is given. For the end item trumpet, we need 1 bell assembly and 1 valve assembly. For the valve assembly, we need 3 slide assemblies and 3 valves. And now, firstly, we check the amount of time required to produce this end item. Let's start from the second level. Let's check the highest production lead time for the components, and as you can see it is 3 weeks. And for the first level, the highest production lead time is 4 weeks. That belongs to valve casing assembly. And now we can say that we need at least 7 weeks to produce this end item. Since it takes 7 weeks to produce a trumpet, we will only consider the forecast for demands that are at least 7 weeks into the future. For example, we will label the current week as week 1 and we will consider the forecast of the trumpets for weeks 8 to 17. And this demand is given in this table. And also, the company receives returns from its various suppliers. These are instruments that are defective for some reason or are damaged in shipping. But once the necessary repairs are completed, these trumpets are returned to the pool of those ready for shipping. And based on the current and anticipated returns, the company expects the following schedule of receipts to the inventory, as given in this table. Moreover, the company also expects to have 23 trumpets in inventory at the end of week 7. And according to this data, we will calculate the MPS for the trumpets. Here we have the demand data and we have the data for the receipts, and we know that we will have an on-hand inventory at the beginning of week 8. Let's check, for example, the forecast for week 8 is 77, but we know that we will receive 12 trumpets in that week, and we have an on-hand inventory of 23 trumpets at the beginning of week 7. So we will subtract this on-hand inventory and the amount of receipt from the forecast 77. And here we obtain the Net predicted demand is 42 for week 8. And we do the similar calculations for the rest of the weeks and obtain the net predicted demand just like in this table. And now we will make MRP calculations for the bell assembly. Let's check bell assembly. Here we have the bell assembly in the bill of materials. We see that we require a single bell assembly for each trumpet, and the production lead time for the bell assemblies is 2 weeks. Here, firstly, we write the gross requirements and net requirements in this table. Since we need a single bell assembly for each trumpet, we do not change the numbers. Okay, we have these numbers. But since the production lead time is 2 weeks for the time phase net requirements, we shift the data 2 weeks previous. Okay, I mean we know that the net requirement of bell assembly, for example, for week 17 is 38, but since the production lead time is 2 weeks, we have to schedule we have to plan order release in the week 15 at an amount of 38. And now, and in this example, by the way, I should also explain that we use a lot for lot production rule. Let me explain what is lot for lot. Lot for lot means that the production quantity each week is just the time phase net requirement. A lot for lot production rule means that no inventory is carried from one period to another. But we will see later, lot for lot is rarely an optimal production rule. But for this example, now we are using lot for lot rule. And now we will make MRP calculation for valve casing assembly. Let's check that component. Here we have the valve casing assembly. Again, we need a single valve casing assembly for the trumpet, but here the lead time changes. It is 4 weeks. So in fact, the MRP calculations are similar to the MRP calculations of the bell assembly, but now the lead time is different. So here for the time phase net requirements and planned order release, we shift the numbers 4 weeks previous. Let's make the MRP calculations for the valves. Let's check the bill of materials. We have the valves in the second level. Here we see that we need 3 valves for each valve casing assembly, and production lead time is 3 weeks. And for the calculations for the gross requirements, in fact we take the gross requirements of valve casing assembly, but since we need 3 valves for each valve cases assembly, we multiply the gross requirements of valve casing assemblies with 3 and obtain the gross requirements for the valves. There are some details given in this part of the problem. It is saying that the company expects an on-hand inventory of 186 valves at the end of week 3. So here for on-hand inventory for week 3 we write 186. Moreover, a receipt from an outside supplier of 96 valves at the start of week 5 is expected. So we write also this receipt for week 5 as 96. And to calculate the net requirements, for example, for week 4, the gross requirements is 126, but we have an on-hand inventory of 186. So we use 126 of this on-hand inventory, and here in week 4 we have an on-hand inventory of 60 units. And for week 5 We have a gross requirement of again 126, but in this period we have a scheduled receipt of 96 units. We also have an on-hand inventory. So we subtract this gross requirement from the receipts and on-hand inventory and obtain 30. And this is our on-hand inventory in week 5, and the net requirement is 0. And for week 6, the gross requirement is 96. Since we have an on-hand inventory of 30, the net requirement is 66. And we take the gross requirements as net requirements for the rest of the periods. And we obtain these net requirements, and we know that production lead time is 3 weeks. For the time-phased net requirements and plant order release, we shift these net requirements 3 periods earlier and obtain these numbers. And that is all for this example. This was a simple example to show you the MRP calculations for a product with a simple bill of materials. And in this example, we used a production plan lot for lot. And as I mentioned before, in fact, this production plan is not optimal for most of the problems. Now I will introduce you some other production plans to determine the lot sizes.